Okay, what is the net capacitance between the terminal point A and B when you have a series of capacitors connected according to this shape? Now, the key here is you have to find the innermost circle first, and you can say that this part is the innermost circle. I can say that C3 and C4 are connected together in series. So I would say C3 is series with C4, which means 1 over C34, the equivalent capacitance for C3 and C4 would be 1 over C3 plus 1 over C4. So I can calculate, so let me just do the calculation. 1 over C34 then would be 1 over C3 is 3 and C4 is 6. So this would be 2 divided by 6 plus 1 over 6, 3 over 6. And so you can say that C34, I can take this C3 and C4 and replace it with one capacitor, like this shape, where the C34 is reverse of 1 over C34, which is 6 divided by 3. So it's 2 microfarad. So we have this C34 now in parallel to C2. And so I would say C2 is now parallel to C34. And so the equivalent capacitor for C2 and C34 would be the sum. So C234, I call it. You can put a comma here so you know which one you're adding. This becomes C2 plus C34. C2 is, let's see, C2 is 4. So I will have 4 microfarad plus 2 microfarad, and this would be 6 microfarad. Now notice that here I just add them together. Okay, so that means I can take these two, C2 and C34, and replace it with a new capacitor with 6 microfarad. Okay, that gives me this shape where the C234 would be 6 microfarad. C1 is 12 microfarad. And so now this 2, C1, again, is in series with C234, thus 1 over equivalent of 1 and 2, 3, 4, if you like, would be 1 over C1 plus 1 over C2, 3, 4. Let me just replace it. 1 over 12 plus 1 over 6. That's like 2 over 12. That's 3 divided by 12, which means C equivalent is 12 divided by 3, which is 4 microfarad. Now I have 3 significant digits, so we will report a number with 3 significant digits. Okay, now let's you have a capacitor and you charge it with a battery of 1.5 volt, and then you store about 2.0 millijoules of energy on this capacitor. Now you change the battery, you put a 3 volt battery. You want to know how much energy is stored on this capacitor now. Well, the energy which is stored in a capacitor in first condition would be half C voltage to the power of 2. C is the capacitance, V is the voltage across the capacitor. The second time, the energy stored on it would be U2 would be half. The capacitance is not changed, so it's the same. But the voltage is now changed to V2, so it becomes V sub 2 to the power of 2, which means the ratio of the energy stored on the capacitor between condition 1 and condition 2 would be simply, because C is the same, it cancels out when I divide them by each other, it would be the ratio of the voltage to the power of 2. Okay, so let's replace them. At the condition 1, we have 2.0 millijoules of energy. We want to know what is the energy at the second condition. The ratio of the voltage is 1.5 to 3 to the power of 2. 1.5 divided by 3 is 1/2. So I will have 1/2 to the power of 2. That's 1/4. So U2, I'm going to isolate for it, would be 2.0 millijoule times 4, which will give me 8 millijoules of energy stored on this capacitor. Or you can simply say that the energy of the capacitor is proportional to the change in the voltage to the power of 2. If you double the voltage, then the energy would change by a factor of 4.